Welcome. This demonstration is brought to you by Digital Den. In part 1 of this blog series, you manually deployed a highly available virtual private cloud that spanned 2 availability zones, setting the foundation for a resilient infrastructure. In part 2, you focused on scalability and high availability. You configured an application load balancer to distribute incoming traffic across instances, enhancing system resilience. A launch template streamlined the instance deployment process through an auto-scaling group, providing you with control and flexibility. By implementing a secure 2-tier architecture and appropriate security group configurations, you ensured robust security. The high availability of your web server was thoroughly tested and demonstrated, including its performance under stress conditions. In part 3, the focus was on improving security and optimizing performance for your application. This involved setting up HTTPS with a valid SSL/TLS certificate from AWS Certificate Manager for your application load balancer. You also utilized Amazon CloudFront as a content delivery network to reduce latency by caching frequently accessed content. Furthermore, security enhancements included the integration of AWS Web Application Firewall with CloudFront. HTTPS was enforced for all user interactions, and access to origin resources was controlled using custom headers and WAF rules. AWS Secrets Manager was employed to automate secret rotation, facilitated by Lambda functions. Code optimization was achieved through the introduction of Lambda layers. A comprehensive review was conducted to ensure the application's continued security and functionality. The objectives encompassed a range of security and performance configurations. Now, in part 4, you focus on enhancing security, improving monitoring, and ensuring compliance for your AWS applications and infrastructure. One key aspect is enhancing security through VPC endpoints. By configuring VPC endpoints for AWS Systems Manager and CloudWatch logs, you establish secure, private communication within your virtual private cloud, reducing exposure to the public internet and fortifying your AWS security. Part 4 also focuses on significant improvements in monitoring capabilities. You will achieve this by installing and configuring the CloudWatch Agent on your Amazon EC2 instances. The CloudWatch Agent efficiently collects metrics, logs, and custom data from your instances, enabling you to closely monitor performance and health. The Run command feature simplifies agent deployment for easier management. Effective monitoring of application and system logs is another highlight. Utilizing Amazon CloudWatch logs, you will generate log data by intentionally triggering errors and access attempts on your web server. Metric filters within CloudWatch logs help identify specific patterns, such as 404 errors. These filters trigger CloudWatch metrics and enable you to set up alarms for conditions like 404 error thresholds. Real-time alerts provide valuable insights into application behavior, facilitating rapid issue resolution. Furthermore, you monitor EC2 instance metrics using Amazon CloudWatch, exploring CPU, disk, and network usage metrics. These insights, both external and internal, thanks to the CloudWatch Agent's data collection, aid in assessing performance and health. You will then set up an AWS CloudTrail for detailed AWS API activity logging. By enabling CloudTrail, you gain comprehensive visibility into changes and actions within your AWS infrastructure. This detailed logging enhances security and supports compliance by providing a comprehensive API activity record. Finally, you will set up AWS Config for assessing, auditing, and evaluating AWS resource configurations. Part 4 demonstrates the activation of the CloudTrail logging-enabled rule within AWS Config, ensuring active AWS CloudTrail logging. This proactive approach to compliance management maintains resource integrity and security. Before we get started, there are several commands that will be utilized throughout various tasks. Please visit my blog for a comprehensive list of these commands. The link to access my blog is provided below. Let's get started. Task 1. Create VPC endpoints to use AWS Systems Manager and CloudWatch logs. In the previous parts of this series, you configured an AWS environment with web servers in private subnets and an application load balancer for routing traffic. NAT gateways were established in public subnets to provide outbound internet connectivity for resources in private subnets. With this current configuration, AWS Systems Manager will work for managing your web servers as they can reach the Systems Manager service via the NAT gateways. The architecture provides a good balance between security and functionality. The resources in the private subnets are shielded from direct internet access, but they can still communicate with external resources when needed. The NAT gateways act as intermediaries for outbound traffic, which helps maintain security by not exposing the internal instances directly to the internet. However, using a NAT gateway with VPC endpoints for Systems Manager can improve the security posture of your web servers. By using an interface VPC endpoint, you can connect to services powered by AWS Private Link. AWS Private Link is a technology that allows you to privately access Amazon EC2 and Systems Manager APIs by using private IP addresses. AWS Private Link restricts all network traffic between your managed instances, Systems Manager, and Amazon EC2 to the Amazon network. This means that your managed instances don't have access to the internet. If you use AWS Private Link, you don't need an internet gateway, a NAT device, or a virtual private gateway. In Task 1, you will create and configure VPC endpoints to use SSM and CloudWatch logs. By doing so, you will improve the security posture of your web servers. Before proceeding, confirm that the AWS Systems Manager agent is correctly installed and operational on your EC2 instance. This step ensures seamless implementation of VPC endpoints for heightened security. In Part 2 of this series, you set up an EC2 Instance Connect endpoint to establish connections with web servers situated within private subnet 1. This endpoint that you have configured will once again come into play for this task. Navigate to the EC2 console. Locate and select the EC2 instance associated with your web server in private subnet 1. Choose Connect. In EC2 Instance Connect for connection type, choose Connect using EC2 Instance Connect endpoint. Choose the appropriate EC2 Instance Connect endpoint associated with your web server. At the bottom of the page, choose Connect. A new browser page will open, establishing a connection to the web server instance. Once connected to the web server instance, execute the systemd service status query command to verify the status of the AWS Systems Manager agent. Review the output of the command. It should indicate that the AWS Systems Manager agent is both installed and running on the instance. When working with AWS Systems Manager, it is important to establish appropriate permissions to ensure smooth interactions with your instances. By default, AWS Systems Manager lacks the necessary authorization to carry out actions on your instances. To enable this functionality, you can provide access on an individual instance level using an AWS Identity and Access Management instance profile. This profile acts as a conduit, conveying IAM role details to an Amazon EC2 instance during its launch. To create an instance profile for Systems Manager, open the IAM console. In the navigation pane, choose Roles. Choose Create Role. For Trusted Entity Type, choose AWS Service. Immediately under Use Case, choose EC2, and then choose Next. On the Add Permissions page, use the search field to locate the Amazon SSM Managed Instance Core Policy. Select the checkbox next to its name. Choose Next. For role name, enter a name for your new instance profile, such as SSM instance profile. Make a note of the role name. You will choose this role when you create new instances that you want to manage by using Systems Manager. Choose Create Role to finalize the creation of the role. The system returns you to the Roles page. Choose View Role. To enable your instances to interact with the CloudWatch service securely and perform the necessary actions for monitoring and analysis, you need to add the CloudWatch Agent server policy to the SSM instance profile. This grants the required permissions for your instances to effectively use the CloudWatch Agent to collect and send metric and log data to CloudWatch. Within the SSM instance profile summary page, choose Add Permissions. Choose Attach Policies. Search for and select the checkbox next to the CloudWatch Agent server policy. Choose Add Permissions. With these steps, the SSM instance profile role gains the necessary permissions for CloudWatch integration. Instances associated with this role can now effectively utilize the CloudWatch Agent. Next, you need to establish the connection between your Systems Manager instance profile and a launch template. Navigate to the EC2 dashboard. In the left navigation pane, choose Launch Templates. Find and select the launch template that corresponds to the instances you want to configure with the Systems Manager instance profile. Inside the selected launch template, choose Actions. In the drop-down menu, choose Modify Template to generate a fresh version of the launch template. Retain the default settings without alteration while generating the new template version. Scroll down and expand the Advanced Details section. Under IAM Instance Profile, choose SSM Instance Profile. Scroll to the bottom of the page and choose Create Template Version. Systems Manager Instance Profile is now integrated with the launch template. Now you need to ensure that your auto-scaling group incorporates the updated launch template with the associated Systems Manager instance profile. In the left navigation pane, choose Auto-scaling Groups. Find and choose the auto-scaling group that corresponds to the instances using the launch template with the attached Systems Manager instance profile. Inside the selected auto-scaling group, choose Actions. Choose Edit. In Launch Template for Version, choose the version you just configured. Scroll to the bottom of the page and choose Update. The auto-scaling group will now use the updated launch template with the associated Systems Manager instance profile. This ensures that new instances launched by the auto-scaling group will have the necessary permissions for efficient management through AWS Systems Manager. When you update the launch template for your auto-scaling group, the new configuration will apply to instances that are launched after the update. After adding a new IAM instance profile to the launch template for AWS Systems Manager integration, you can update running instances by terminating them. When the auto-scaling group replaces these terminated instances, the new instances will have the updated IAM instance profile attached. To terminate instances, in the left navigation pane, choose Instances. Select the web server instances by clicking on the checkboxes next to them. In the Actions menu at the top of the instance list, choose Instance State. Choose Terminate. Since you are using auto-scaling, terminated instances will be automatically replaced by new instances that conform to your launch template settings. Once the new instances are launched and running, select one of the instances. Go to the Security tab, and under IAM Role, verify that the new IAM instance profile, SSM instance profile, is attached to the instances. By terminating the existing instances and letting the auto-scaling group launch new instances, you're effectively applying the new IAM instance profile. Next, you will establish the necessary VPC endpoints for AWS Systems Manager and CloudWatch logs to enable secure communication within your VPC. Before proceeding, create a security group that permits inbound HTTPS on port 443 traffic from VPC resources communicating with the service. Open the Amazon VPC console. In the left navigation pane, choose Security Groups. Choose Create Security Group. Enter the name, VPC Endpoint SG. Add a description to provide context, such as Security Group for Systems Manager VPC Endpoints. For VPC, choose the VPC from which you'll be accessing the AWS service. Under Inbound Rules, choose Add Rule. For type, choose HTTPS. For source, enter your VPC CIDR. This ensures that any resource within your VPC can send inbound HTTPS traffic to the security group associated with the VPC endpoints. Choose Create Security Group. Firstly, you need to create 3 required and 1 optional interface endpoints for Systems Manager. The first 3 endpoints are required for Systems Manager to work in a VPC. You can also establish a private connection between your VPC and CloudWatch logs. You can use this connection to send logs to CloudWatch logs without sending them through the internet. To start, configure the first required VPC endpoints for AWS Systems Manager. In the navigation pane, choose Endpoints. Choose Create Endpoint. In Service category, choose AWS Services. For service name, choose SSM. For VPC, choose the VPC ID of the instances you want to manage. For subnets, choose the subnets where the endpoints are going to be deployed. This helps ensure accessibility to the endpoint from different zones. For security groups, choose the security group VPC Endpoint SG you created. For policy, select Full Access to allow all operations by all principals on all resources over the VPC endpoint. Otherwise, select Custom to attach a VPC endpoint policy that controls the permissions that principals have for performing actions on resources over the VPC endpoint. Choose Create Endpoint. Next, configure 3 more endpoints for SSM and 1 more for CloudWatch logs. Repeat the step, ensuring you use the same VPC Endpoint SG. The EC2 messages is an endpoint for SSM agent to communicate with Systems Manager service. The EC2 endpoint is necessary if using Systems Manager for VSS-enabled snapshots. The SSM messages endpoint is required only if you are connecting to your instances through a secure data channel using Session Manager. The logs endpoint is optional. However, it can be created if you want to use Amazon CloudWatch logs for Session Manager, Run Command, or SSM agent logs. By following these steps, you will have successfully established the required VPC endpoints for AWS Systems Manager Services and CloudWatch logs. These endpoints enhance security and efficiency for communication within your VPC. Task 2. Use AWS Systems Manager Run command to install the CloudWatch Agent on Amazon EC2 instances. The CloudWatch Agent is a versatile tool that gathers a wide range of metrics from both EC2 instances and on-premises servers. This installation will enable you to collect system-level metrics, logs, and custom metrics, significantly enhancing your monitoring capabilities. First, install the CloudWatch Agent. Navigate to the Systems Manager console. In the left navigation pane, choose Run command under Node Management. Here, you will use the Run command feature to execute a predefined command that will install the CloudWatch Agent. Choose Run a command. Select the radio button next to AWS Config AWS package. Scroll down to the Command Parameters section. Under Action, choose Install. For name, enter Amazon CloudWatch Agent. For version, enter latest. In the Targets section, select Choose Instances manually. Choose both web servers. This action will install the CloudWatch Agent on these instances. At the bottom of the page, choose Run. Wait for the overall status to change to Success. You can occasionally choose Refresh towards the top of the page to update the status. You can view the output from the job to confirm that it ran successfully. Under Targets and Outputs, choose the instance ID displayed. Expand Step 2 - Command Description and Status. You should see the message Successfully installed Amazon CloudWatch Agent. You will now configure CloudWatch Agent to collect the desired log information. The instance has a web server installed, so you will configure CloudWatch Agent to collect the web server logs and also general system metrics. You will store the configuration file in AWS Systems Manager Parameter Store, which can then be fetched by the CloudWatch Agent. In the left navigation pane, choose Parameter Store. Choose Create Parameter and for name enter Monitor Web Server. For description enter Collect Web Logs and System Metrics. For value, paste the JSON configuration. This JSON configuration defines how logs and metrics are collected for monitoring purposes. Logs from HTTP access log and HTTP error log will be sent to CloudWatch logs, and various system metrics will be collected and sent to CloudWatch at a 10-second interval. Choose Create Parameter. You will now use another Run command to start the CloudWatch Agent on the web servers. In the left navigation pane, choose Run command. Choose Run command. Choose Search. Enter Amazon CloudWatch Manage Agent and press Enter. Before executing the command, you can review its definition. Click on Amazon CloudWatch Manage Agent. A new tab will open, displaying the command's definition. Browse through the content to understand how a command document is defined. Choose the Content tab and scroll to the bottom to see the actual script that will run on the target instance. On the Content tab, you can see the script that will run on the instance. This script references the AWS Systems Manager parameter store to fetch the CloudWatch Agent configuration. Close this tab to return to the Run command tab. Verify that you have selected the radio button next to Amazon CloudWatch Manage Agent. In the Command Parameters section for action, choose Configure. For mode, choose EC2. For optional configuration source, choose SSM. For optional configuration location, choose Monitor Web Server. For optional restart, choose Yes. This configures the agent to use the configuration you previously stored in the parameter store. In the Targets panel below, select Choose Instances manually. In the Instances section, select both web servers. Choose Run. Wait for the overall status to change to Success. You can occasionally choose Refresh towards the top of the page to update the status. The CloudWatch agent is now running on the instance, sending log and metric data to CloudWatch. By following these steps, you have successfully installed and configured the CloudWatch agent on your instances, enhancing your monitoring capabilities. This information is invaluable for tracking system health, diagnosing issues, and optimizing performance. Task 3. Monitor application logs using CloudWatch Agent and CloudWatch Logs. You can use Amazon CloudWatch Logs to monitor applications and systems using log data. For example, CloudWatch Logs can track the number of errors that occur in your application logs and send you a notification whenever the rate of errors exceeds a threshold you specify. CloudWatch Logs uses your existing log data for monitoring, so no code changes are required. For example, you can monitor application logs for specific literal terms such as null reference exception, or count the number of occurrences of a literal term at a particular position in log data, such as 404 status codes in Web Server Access Log. When the term you are searching for is found, CloudWatch Logs reports the data to a CloudWatch metric that you specify. Log data is encrypted while in transit and while it is at rest. In this task, you will generate log data on the web server, then monitor the logs using CloudWatch Logs. First, generate log data on the web server. Open a new web browser tab, enter your custom domain name and press Enter. Confirm that your web page is visible. You will now generate log data by attempting to access a page that does not exist. Append Start to the browser URL and press Enter. An error message will appear as the page is not found. This will generate data in the access logs sent to CloudWatch Logs. Keep this tab open in your web browser, but in a new tab navigate to the CloudWatch console. In the left navigation pane, expand Logs, choose Log Groups. You should see two logs listed, HTTP access log and HTTP error log. If these logs are not listed, try waiting a minute, then choose Refresh. Choose HTTP access log. Choose the value, instance ID displayed under log streams. Log data should be displayed, consisting of GET requests that were sent to the web server. You can view further information by expanding the lines. The log data includes information about the computer and browser that made the request. In the search box, enter 404 and press enter. You should see lines with your start request with a code of 404, which means that the page was not found. This demonstrates how log files can be automatically shipped from an Amazon EC2 instance, or an on-premises server, to CloudWatch logs. The log data is accessible without having to log into each individual server. Log data can also be collected from multiple servers, such as an auto-scaling fleet of web servers. You will now configure a filter to identify 404 errors in the log file. This would normally be an indication that the web server is generating invalid links that users are clicking. Navigate to Log Groups. Select the checkbox next to HTTP Access Log. From the Actions drop-down, select Create Metric Filter. A filter pattern defines the fields in the log file and filters the data for specific values. Paste the line into filter pattern. This tells CloudWatch logs how to interpret the fields in the log data and defines a filter to only find lines with status code 404. This indicates that a page was not found. Under Test Pattern, use the drop-down menu to select an EC2 instance ID. Choose Test Pattern. In the Results section, choose Show Test Results. You should see at least one result with a status code of 404. This indicates that a page was requested that was not found. Choose Next. For filter name, enter 404 errors. In metric details, for metric namespace, enter log metrics. For metric name, enter 404 errors. For metric value, enter 1. Choose Next. On the Review and Create page, choose Create Metric Filter. The metric filter is now ready to be used in an alarm for monitoring 404 errors. You will now configure an alarm to send a notification when too many 404 not found errors are received. In the panel titled 404 Errors, choose the checkbox in the top right corner. Next to Metric Filters, choose Create Alarm. For period, enter 1 minute. For conditions, whenever 404 errors is greater or equal than 5. Choose Next. For send a notification to the following SNS topic, choose Create New Topic. For email endpoints that will receive the notification, enter an email address that you can access. Choose Create Topic. Choose Next. For alarm name, enter 404 errors. For alarm description, enter alert when too many 404s detected on an instance. Choose Next. Choose Create Alarm. Go to your email, look for a confirmation message and select the Confirm Subscription link. Return to the CloudWatch console. Expand Alarms, choose All Alarms. Your alarm should appear in gray, indicating that there is insufficient data to trigger the alarm. This is because no data has been received in the past minute. You will now access the web server to generate log data. Return to the web browser tab with the web server. Attempt to go to pages that do not exist by adding a page name after the IP address. Repeat this at least 5 times. Each separate request will generate a separate log entry. Wait 1 to 2 minutes for the alarm to trigger. You can occasionally choose refresh to update the status. The graph shown on the CloudWatch page should turn red to indicate that it is in the alarm state. Check your email. You should have received an email titled Alarm 404 Errors. This demonstrates how you can create an alarm from application log data and receive alerts when unusual behavior is detected in the log file. The log file is easily accessible within Amazon CloudWatch Logs to perform further analysis to diagnose the activities that led to the alarm being triggered. By following these steps, you've successfully monitored application logs using CloudWatch Logs and set up alarms to receive notifications when specific log conditions are met. Task 4. Monitor system metrics using CloudWatch Agent and CloudWatch Metrics. Metrics are data about the performance of your systems. Amazon CloudWatch stores metrics for AWS services you use. You can also publish your own application metrics either via CloudWatch Agent or directly from your application. Amazon CloudWatch can present the metrics for search, graphs, dashboards, and alarms. In this task, you will explore metrics provided by Amazon CloudWatch. Navigate to the EC2 console, and in the left navigation pane, choose Instances. Select a web server instance. Choose the Monitoring tab in the lower half of the page. Examine the metrics presented. You can also choose a chart to display more information. CloudWatch captures metrics about CPU, disk and network usage on the instance. These metrics view the instance from the outside as a virtual machine but do not give insight into what is running inside the instance, such as measuring free memory or free disk space. Fortunately, you can obtain information about what is happening inside the instance by using information captured by CloudWatch Agent, because CloudWatch Agent runs inside the instance to collect metrics. Navigate to Amazon CloudWatch. In the left navigation pane, expand Metrics and choose All Metrics. The lower half of the page will display the various metrics that have been collected by CloudWatch. Some are automatically generated by AWS while others were collected by the CloudWatch Agent. Choose CW Agent, then Device, EFS type, Host, Path. You will see the disk space metrics being captured by CloudWatch Agent. Choose CW Agent, in a line that says All. Choose Host. You will see metrics relating to system memory. Choose All. Explore the other metrics that are being captured by CloudWatch. These are automatically generated metrics coming from the AWS services that have been used in this AWS account. You can select metrics that you wish to appear on the graph. Through this exploration, you can gain valuable insights into the performance and behavior of your instances, enabling you to make informed decisions and ensure optimal system operation. Task 5. Create real-time notifications with CloudWatch Events. Amazon CloudWatch Events delivers a near real-time stream of system events that describe changes in AWS resources. Simple rules can match events and route them to one or more target functions or streams. CloudWatch Events becomes aware of operational changes as they occur. CloudWatch Events responds to these operational changes and takes corrective action as necessary, by sending messages to respond to the environment, activating functions, making changes, and capturing state information. You can also use CloudWatch Events to schedule automated actions that self-trigger at certain times using cron or rate expressions. In this task, you will establish a real-time notification mechanism to alert you when an instance is either stopped or terminated. Navigate to Amazon Event Bridge. In the left navigation pane, choose Rules. Choose Create Rule. For name, enter Instance Stopped Terminated. Choose Next. In the Event Patterns section near the bottom of the page, in Event Source, from the drop-down list, choose AWS Services. In AWS Service, from the drop-down list, choose EC2. In Event Type, from the drop-down list, choose EC2 Instance State Change Notification. In Event Type Specification 1 Specific States. From the drop-down list, choose Stopped and Terminated. Choose Next. In the Target 1 section, from the Select a Target drop-down list, choose SNS Topic. From the Topic drop-down list, choose Default CloudWatch Alarms Topic and choose Next. On the Configure Tags - Optional page, choose Next. On the Review and Create page, choose Create Rule. Through this process, you have established a rule within CloudWatch events that responds to EC2 instance state changes. Specifically, you will receive notifications when instances are either stopped or terminated, enabling you to stay informed about critical changes to your resources. Next, review the real-time notification configuration. Navigate to the EC2 console, and in the left navigation pane, choose Instances. Select a web server. Choose Instance State, then Stop Instance, then Stop. The web server instance will enter the stopping state. After a minute it will enter the stopped state. You should then receive an email with details of the instance that was stopped. This demonstrates how easy it is to receive real-time notifications when infrastructure changes. Task 6. Set up AWS CloudTrail for detailed logging of AWS API activity. Enabling AWS CloudTrail is a fundamental practice in effectively managing and enhancing the security of your AWS environment. It adds a vital layer of visibility and control, supporting the maintenance of resource integrity, security, and compliance. By capturing detailed logs of API activity, CloudTrail empowers you with insights into how your AWS resources are being utilized. In this task, you will establish an AWS CloudTrail trail in your AWS account to capture essential API activity logs. Navigate to the CloudTrail console. In the left navigation pane, choose Trails and then choose Create Trail. For trail name, enter Monitor. For storage location, choose Create a new S3 bucket. For trail log bucket and folder, enter monitoring followed by 4 random digits. Log file SSEKMS encryption is set to enabled by default. This encrypts CloudTrail log files by using the AWS Key Management Service. For AWS KMS alias, choose New, and then enter CloudTrail encryption key. For CloudWatch logs optional, choose Enabled. For log group name, choose New and keep the default log group name. For role name, choose New and enter CloudTrail role for CloudWatch logs monitor. When you configure a CloudTrail trail to send events to CloudWatch logs, you choose a destination for those events. You specify an existing CloudWatch logs log group, or create a new one to send your events to. Keep the other default trail attributes and choose Next. In the Choose Log Events screen for event type, keep Management Events checked. For API activity, keep Read and Write selected. Choose Next. Scroll down and choose Create Trail. By completing this process, you've successfully established an AWS CloudTrail trail. This trail will capture API activity logs, providing you with an extensive record of actions taken within your AWS environment. This data will enhance your ability to monitor and secure your resources effectively. Task 7. Track infrastructure compliance using AWS Config. AWS Config is a powerful service designed to assess, audit, and evaluate the configurations of your AWS resources. By continually monitoring and recording the configurations of your resources, AWS Config empowers you to automate the evaluation of recorded configurations against desired settings. This facilitates the review of configuration changes, resource relationships, and detailed configuration histories, ultimately aiding in compliance auditing, security analysis, change management, and operational troubleshooting. In this task, you will activate the CloudTrail logging-enabled rule within AWS Config. This rule ensures that AWS CloudTrail logging is active, allowing you to gain crucial insights into API activity occurring across your AWS account. Navigate to AWS Config. If a Setup AWS Config message appears, choose one-click Setup. Choose Confirm. You will now add a rule that checks if AWS CloudTrail logging is enabled in all regions. In the left navigation pane, choose Rules. Choose Add Rule. In the search field under AWS Managed Rules, enter CloudTrail CloudWatch Logs Enabled. Choose the radio button that appears next to the rule and choose Next. In the Configure Rule page, choose Next. Review the AWS config settings, choose Save. Choose the drop-down menu under Rules and select All to view all rules. Wait until at least one of the rules has completed evaluation. Choose Refresh every 60 seconds to update the status. Choose the CloudTrail CloudWatch Logs Enabled rule. Choose the drop-down box under the Resources in Scope section and select All. Amongst the results should be a compliant CloudTrail trail. It's important to note that AWS Config provides an extensive library of predefined compliance checks, and you can even craft your own checks by creating custom AWS Config rules using AWS Lambda functions. By completing this task, you've taken a crucial step towards maintaining compliance and security across your AWS resources. That wraps up part 4 of traditional web hosting on AWS. In this installment, you have taken several important steps. You enhance security by setting up VPC endpoints for private communication. You improved monitoring by deploying the CloudWatch Agent on EC2 instances. You effectively monitored logs using CloudWatch logs. You set up AWS CloudTrail for detailed API activity logging. You used AWS Config to assess resource configurations for compliance. These actions help ensure a secure, well-monitored, and compliant AWS environment.